While JavaScript classes cannot inherit from multiple superclasses, we can still mix functionality from various classes. So because JavaScript is linked list, unlike with class oriented programming language, it cannot inherit from multiple superclasses. We can still mix functionality from various classes, just as how we um, mix objects and prototypes and scripts by importing it with one another, assuming that they won't follow this inheritance way of relating the code, because that's just not the built-in JavaScript works. So by this time, I hope you already understand that, guys, a class in JavaScript can be used as an expression as well as a statement. As an expression, it returns a new class each time it's evaluated. So if you use like an expression, if a class is being used as an expression, it will instantiate a new class. The extends clause can also it will extend or it will instantiate a new class once it's evaluated at runtime. So that's how a class expression works in JavaScript. The extends clause can also accept arbitrary expressions that return classes or constructors. So if you add an extend clause to that class expression that returns a new class or instantiate a new class at runtime, you can accept like an arbitrary expression that not just return a class but also a constructor. So you can further modify it via extend keyword. The features enable us to define a mixin as a function that accepts a superclass and creates a new subclass from it. So based on that principle, we can create a mixin pattern or a function or a prototype that accepts a superclass, quote unquote superclass, but it's still just a prototype, and creates a new subclass from it, whether we're instantiating a new class or modifying it based on our local code, such as constructor. Imagine that we define a mixin containing utility functions in a standard JavaScript class as follows. So here we create const mymixins equals superclass and an arrow function class extends superclass, and then inside we have move up function, and then inside is a console.log move up, and then move up down function with an empty as well, empty parameter, console.log move down, and then stop function, empty parameter, and then console.log stop in the name of love. So here we created my mixin function that can extend a dynamic superclass. So this object that we created, or rather a multiple function, extend the dynamic superclass that we have defined before. We will now create two classes, car animator and person animator, from which mymixins can extend and return a subclass with methods defined in mymixins and those in the class being extended. So basically, you can think of this as a higher order function with React in which you use this function as a parameter to the next function that will transform this function into a new function, or in this case is a class. So a skeleton car animator constructor class car animator, inside is a move left empty parameter function with a console.log string move left and closing, and then a skeleton person animator constructor. So we have class person animator, inside is move randomly function, and then inside is an empty and then closing, and then extend my mixin extend my mixins using car animator. So class my animators, or extend my mixins. So we create a new class that extend my mixins with a parameter of the car animator. So as you can see in this module, we have three classes. Okay, so we define first the parameter that we would use to my mixins, or sorry, my animator that will transform the car animator, that will use my mixin to transform it to a new class. So here, create a new instance of car animator, const my animator equal new my animator function closing, and then we will call now this new instantiated object with its specify. So since we create this object, so all of this my animator that we define here object is now instantiated once the CPU gets into this code. So when it is instantiated, therefore all of the available methods inside it will be available. Now we can now call those available methods separately. So basically we're copying or referencing that one by one. So my animator that move left method, my animator that move now, my animator that stop. So it outputs move left, move down, and stop in the name of lot. As we can see, because of this, there's no reason to combine similar behavior in a class, because we can just extend behavior like this. So this is also a type of like function decomposition, or so in React we basically avoids this extends, right? This is like this is good because you're trying to like organize the code in its functionality, and it's easy to test for a return value. But there is a better way, which we will discuss in the future, which is just composition, function decomposition, or composition inheritance. But basically you're creating like a function, smaller function that is not aware of the parent or subclass method, because as you can see, this my animator is now highly interconnected to the my mixins that we create, or its super class. You can think of it like a parent, because we need we use a class and extend. So now these are now interrelated to that, but for like more efficient way or modern way of doing things, you can actually avoid that altogether. So you can use those advantages of this that allows you to like decompose the functions, but at the same time allow you to avoid those overhead. The following example has two classes, a car and a mixin. What we're going to do is augment, another way of saying extend, the car so that it can inherit specific methods defined in the mixin. So here we will create a class car, that augment or extend the methods we define in the mixin. So remember, we can override or extend the superclass. So namely, drive forward function and drive backward. This example will demonstrate how to augment a constructor to include functionality without the need to duplicate this process for every constructor function we may have. So here, aside from just extending or transforming our superclass, here we will learn how to extend that without duplicating copies. So we are maximizing the resources. And also another concept is that what we are really extending is the constructor or an object that has been created at runtime and import. So remember in the previous videos that when we import something at the top, or when we have line of codes at the top, those will be instantiated first before at the bottom. So if those are instantiated, then we might as well use those and then avoid duplication in our code. So here, class car, inside is a constructor with a key value with a member model with a value string, no model provided, and a member caller with a value no caller provided. Inside is a this dot model equal to model, and then semicolon, and then this dot caller equal to caller, semicolon, then closing. Then export default car, so that's car.js. So here mixin.js and index.js remain unchanged, the one we described earlier. So here's the index.js, import car from /car.js, semicolon. The next line, import mixin from /mixin.js, semicolon. Then class myCar extends mixin with a parameter car, and then empty open and semi-curly bracket, or empty object. Then create a new car, const myCar equal new myCar, parentheses, inside is an empty object, and then closing. Then test to make sure we now have access to the methods myCar that drive forward function, semicolon, then myCar that drive forward function, semicolon. This should outputs drive forward and drive backward. So drive forward, and then const my sports car equal new my car, object with a key or member model with the value Porsche, comma, with the member caller with the value string red, comma, and then closing. Then my sports car that drives sideways function, semicolon, it outputs drive sideways. So you are trying to locate the mixin in the code as if it were a normal class file. You're expecting where's the parent class, where's the inheritance tree. But mixin is not a class in the normal sense. You're looking for a thing. A mixin is actually a function that manufactures a class. So basically, you can think of this as a function, or again a superclass that basically manufacture or create multiple classes from it. The single idea is the key. First, what class myCar extends my mixin parameter car actually mean? So this line, class myCar extend mixin parameter car empty object, looks like inheritance, but something very strange is happening. The extends keyword normally specs. Extends sum class. Example, class dog extends animal, empty object. But here you pass extends mixin with a parameter car instead of extending a class. So that is not a class name, that is a function call. So that's also how it is different with a class-oriented programming language, in which it extends it's a function call, it extends a function call to use as its superclass, or in this case, it's actually a mixin pattern. So JavaScript does this. First, call mixin parameter car. Then second, the functions, the function returns a new class. So this function, the mixin with the parameter car, will return a new class. Then third, myCar extends that return class. So the inheritance change is actually from car to class returned by mixin with the parameter car, and then to myCar, because myCar extends those things that were transformed. You never see the middle class because it was generated at runtime. The invisible middle class is the mixin. So again, this pattern are basically optimizing for runtime. Once you get this, or once someone instantiated, kind of like how TypeScript optimize in runtime how those types converted. So that invisible middle class in runtime that optimize your code is the mixin. So as you can see, it's linked list as well. It's not a superclass, but it allows you again to reuse your function that's already there. So again, it's maximizing resources, it's mixin. Where is mixin.js really? Here's what the missing file logically looks like mixin.js, export default function, mixin, parameter superclass, and then object opening, return first line, return class extends superclass. Then object opening, we have three function that has the console in it: drive forward, drive backward, drive sideways. So all of this has an empty parameter, and the console.log drive forward, drive backward, drive sideways, and then closing. That's why we see those being returned earlier as a drive forward and drive backward. So those are missing in the document. That's why we're not able to see it. This is extremely important. A mixin is not a parent, a utility file, a service. A mixin is a function that takes a class and returns a new enhanced class. It is literally a class transformer. What actually happens in memory? When this runs, class myCar extends mixin parameter car empty object. JavaScript secretly does const mixedCar equal mixin parameter car closing, then class myCar extends mixedCar empty object, and mixin parameter car does create a new class, copy car behavior, add new methods, return it. So myCar is a car that has been upgraded, not a different species, not a different type hierarchy, an upgraded capability. This is why mixin solve the multiple inheritance problem. So as you can see, just as with the superclass, which allows you to override or add new or delete methods, it also does that here, but it's in a different way. And also the hierarchy is still the same, it's still the same species, just as you would with the superclass and a subclass. Why this exists at all? Because the real world is not hierarchical. You instinctively discover this in LiveKit. So let's map: doctor, authenticate, join room, send message, moderate; patient, authenticate, join room, send message, cannot moderate; moderator, moderate, mute, kick. These are capabilities, not identities. If you use class inheritance, you have user, then doctor, then patient, then moderator. It breaks immediately because a doctor can also be a moderator. So instead, user can join room, user can send message, user can moderate. Those can something are conceptually mixins. You actually implemented mixins architecturally, even if not syntactically. So your policy files, ai-entitlement-policy.ts, doctor-routes.ts, invitation-access-core.ts are basically behavior composition modules. This is the same design philosophy as mixins. Why mixins are not the same as prototype? This is a major confusion you had. Prototype, where functions live in memory. So again, a prototype is where functions live in memory. So what address is that function currently live in memory? Mixin, where behavior is organized in architecture. Prototype is for performance model. Mixin is for capability model. So how would you organize the behavior in the architecture depending on your specific use? So even if you never write a mixin, prototypes are still working, but mixins are design decisions. The deep essence, the one to remember, inheritance says you are this, mixin says you can do this, factory says you are created this way, singleton says only one of you exists, policy says you are allowed to do this. Your like kit system is primarily policy plus capability, not inheritance. That's why traditional OOP started feeling uncomfortable to you. You were modeling a permission multi-actor system, not a taxonomy. Why your brain couldn't find the mixin? Because you expected class moderator extends user. But mixins don't show up as clean trees. They show up as cross-cutting behavior. And your project structurally actually already showed this. You don't have doctor extends moderator extends user. Instead, you have services slash contract slash policy slash route slash. That is not OOP hierarchy. That is composed behavior architecture, the modern style used in large systems. The single sentence to remember: a superclass defines what something is, a mixins define what something can do, and your live kit up is fundamentally a system about what participants are allowed and able to do, which is exactly why mixin thinking naturally appears even if you never write mixin.js. Mixins assist in decreasing functional repetition and increasing function reuse in a system. So, because a prototype is like where function lives in memory, it's the same with like sharing behavior we discussed with a prototype. It decreases that function repetition because you're able to just copy that existing thing instead of like doing that imperatively from the start, and then it allows you to increase the function reuse. Where application is likely to require shared behavior across object instances, we can easily avoid duplication by maintaining the shared functionality in a mixin and thus focusing on implementing only the functionality in our system which is truly distinct. So if you have like shared behavior, you can just use that same behavior instead of like creating or implementing another code that will function as your value to the business. So like you will just create those few simple functions that allows you to like that which is truly distinct in your app, that allows you to provide more value and allows you to have more energy to create those distinct functions. That said, the downsides to mixins are a little more debatable. Some developers feel that injecting functionality into a class or an object prototype is a bad idea as it leads to both prototype pollution and a level of uncertainty regarding the origin of our function. So there's a downside, of course, in this, in that you may be over using a function that could be in a separate to be more human readable. And another thing is that it could be hard to test your function if a lot of components are depending on it. In large systems, this may be well be the case. Even with React, mixins were often used to add functionality to components before the introduction of ES6 classes. So before the ES6 that has no like when JavaScript doesn't have classes, this is the pattern being used in React. The React team discourages mixins because it adds unnecessary complexity to a component, making it hard to maintain and reuse. So, counterintuitively, though you're maximizing resources, you're reusing it. In a human perspective, it's actually hard to read and therefore it's hard to even use, even if you're maximizing the resources under hood. The React team encourage using higher order components and hooks instead. The decorator pattern. Decorators are a structural design pattern that aims to promote code reuse. Like mixins, you can think of them as another viable alternative to object subclassing. Decorators are structural design patterns that aims to promote code reuse. Oh, let's repeat this. A common reason developers use them is that their applications may contain features requiring many distinct types of objects. So a common use for this is if an application requires a different type of objects for its features. Imagine defining hundreds of different object constructors for say a JavaScript game. So if you imagine like defining or creating a constructor like the object or constructor pattern we discussed in the previous chapter for each like object, like it would be hard to read and maintain. So if we then factored in capabilities, imagine having to create subclasses for each combination of capability types for each of those constructor, like hobby with ring, hobby with sword, hobby with ring and sword, and so on. This isn't practical and certainly isn't manageable when we factor in an increasing number of different abilities.